Thermodynamics in Biosystem Module 2 Basic Concept of Thermodynamics Segment 1 System and its Properties. With me, Yusuf from School of Life Sciences and Technology, Institut Teknologi Bandung. In this module, we will discuss system and its properties, state and equilibrium, processes and cycles, temperature, pressure, and problem-solving technique. A system can be defined as a quantity of matter or a region in space chosen for study. The mass or region outside the system is called the surroundings. The real or imaginary surface that separates the system from its surroundings is called the boundary. The boundary of a system can be fixed or movable. Note that the boundary is the contact surface shared by both the system and the surroundings. Mathematically speaking, the boundary has zero thickness, and thus it can neither contain any mass nor occupy any volume in space. There are three types of systems, particularly closed, isolated, or open system, depending on whether a fixed mass or a fixed volume in space is chosen for study. A closed system is also known as a control mass, consists of a fixed amount of mass and no mass can cross its boundary. That is, no mass can enter or leave a closed system as shown in the figure. But energy in the form of heat or work can cross the boundary, and the volume of a closed system does not have to be fixed. For isolated system, both mass and energy are not allowed to cross the boundary. An open system, which is also known as a control volume, is a properly selected region in space. Both mass and energy can cross the boundary of a control volume. All devices that involve mass flow should be analyzed as open systems instead of closed systems. In general, any arbitrary region in space can be selected as a control volume. There are no concrete rules for the selection of control volumes, but the proper choice certainly makes the analysis much easier. The boundaries of control volume are called a control surface, and they can be real or imaginary. A control volume can be fixed in size and shape, or it may involve a moving boundary as shown in the figure. A control volume can also involve heat and work interactions, just as a closed system, in addition to mass interaction. Properties of a system. Any characteristic of a system is called property. Some familiar properties are pressure, temperature, volume, mass, and many others. Properties are considered to be either intensive or extensive. Intensive properties are those that are independent of the mass of a system, such as temperature, pressure, and density. Extensive properties are those whose values depend on the size or extent of the system, such as total mass, total volume, and total momentum. The symbols are commonly written using uppercase letters, whereas the symbols for intensive properties are often written using lowercase letters. Extensive properties per unit mass are called specific properties. Some examples of specific properties are specific volumes and specific total energy. Continuum. Matter is made of atoms that are widely spaced in the gas phase. However, it is very convenient to disregard the atomic nature of a substance and view it as a continuous, homogeneous matter with no holes, that is, a continuum. The continuum idealization allows us to treat properties as point functions and to assume the properties vary continually in space with no jump discontinuities. This idealization is valid as long as the size of the system we deal is very large relative to the space between the molecules. The continuum idealization is implicit in many engineering problems, such as the density of water in a glass is the same at any point. Density and specific gravity. Density can be defined as the mass per unit volume as shown in equation 1. The reciprocal of a density is the specific volume, which is defined as volume per unit mass as shown in equation 2. For a differential volume element of mass and volume, density can be expressed as shown in equation 3. The density of a substance in general depends on temperature and pressure. The density of most gases is proportional to pressure and inversely proportional to temperature. Liquids and solids, on the other hand, are essentially incompressible substances, and the variation of their density with pressure is usually negligible. The density of a substance can also be expressed relative to the density of a well-known substance, defined as specific gravity or relative density. Specific gravity is defined as the ratio of the density of a substance to the density of some standard substance at a specified temperature as shown in equation 4. The weight of a unit volume of a substance is called specific weight. The densities of liquids are essentially constant, and thus they can often be approximated as being incompressible substances during most processes without sacrificing much accuracy. In the next segment, we will discuss about state and equilibrium. Until then, I am Yusuf from Institut Teknologi Bandung.